Hello everyone! This video will be on the 3.4 section of the IB curriculum. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes the section is radian measure is more standard and more useful for calculations of arc and sectors. Let's start with the idea of a circle. Given a circle, we can draw two lines from the center to the edge to identify an angle. Let's draw it like this. What does the angle look like to you? That looks like 90 degrees, right? But here's a question. Where does that 90 degrees come from? Isn't it odd that out of all the numbers, 90 came in? Why does it have to be 90? Aside from the historic significance of the 360 degree system, it is not so intuitive. Therefore, we're introducing a different unit of angle, and it's called radian. The radian focuses on the relativeness of the angle compared to the full turn. How big is a full turn? Well, that's why we drew the circle. A full turn in a circle, if the radius is 1, a full turn is, well, the circumference is 2 pi r, so it's 2 pi. Therefore, we can declare that a full turn is defined as 2 pi radian. I hope this is a more natural way to express an angle, rather than a 360 degrees method. Let's go back to our example. How big of a turn is it? It's a quarter of a full turn, right? It's a quarter of 2 pi, therefore, it's pi over 2 radian. Does it make sense? Let's quickly talk about the conversion between radians and degrees. The conversion factor is pi over 180, or 180 over pi, depending on which way you want to go. If you're confused, always remember that 2 pi radians is equal to 360 degrees. Okay? I just confused while recording this, so remember that 2 pi and 360. Based on this, we know that 1 radian is 180 over pi, and then 1 degree is pi over 180 radian. Also, we have to convert not only our brain, but also our calculator. Let's take out your calculator and press the mode button near the top. When you see the third row, you can see the mode between the radian and degree. Most cases in IB exams, you'll use the radian, so make sure that the radian is toggled on. Okay, if you want to go back to the degree, you can press enter there, now it's degree. If you want to go to radian, press radian, and we're done. You might be wondering, why do we use radians? Well, as I just told you, it is a more natural way to express angle, and also it makes the calculation process much simpler in future. This will become more apparent in 3.7 when we talk about the trig functions. But now, let's focus on the arc and sector. The arc is a section of a circumference. You could say that this is an extension of an angle because to find the length of an arc, we need to use the angle. Given that the angle is in radian, we simply multiply the angle with the radius to get the length of an arc. Let's try an example. Let's say that we have this triangle, a circle with the radius of 4. And then we have an angle, and that's given as pi over 3. Okay. To find the length of an arc, we're going to use the formula L equals r theta, where theta is the angle in radian, Well, L equals 4 times pi over 3. So L is 4 pi over 3. Straightforward, right? Now we identify an arc. The next step of our curiosity obviously leads to the area. Point, length, area, volume. That's the order we go. The area enclosed by 2 radius arms and an arc, the shape is called a sector. The green part is our sector. The area can be calculated by, again, listed in the formula booklet, by multiplying 1 over 2 times r squared times theta, where theta is the angle, again, in radians. So let's go back to the example here. Let's find the area of our sector. Well, I know A equals 1 over 2 r squared theta. A, let's put all the values are in. Put into formula, and boom. The area is 8 pi over 3 units squared. One way to verify that the formula are correct would be to think about the relation to the full circle. The circumference of the circle over here was 8 pi. What am I writing? 8 pi. And pi over 3, it's a 1/6 of an entire turn. Therefore, the length of an arc should be 1/6 of an 8 pi. 8 pi over 6, 4 pi over 3. And same thing for the sector. The entire area of the full circle is pi r squared, so 16 pi. Again, 1/6 of that, 16 pi over 3, 16 pi over 6, the area is 8 pi over 3. One thing that you should be careful of is to check that the given angle is in radians. The unit of degrees will not work with the formula. Also, make sure that you switch the calculator to the radian mode. I hope you enjoyed this video, and try some questions in this section to really master the skills that we've learned. Anyways, I will see you in the next video. Best wishes.